Have you ever wondered how music and mathematics are related? How the sound of a beautiful melody can be explained by numbers and equations? In this video, we will explore the fascinating science of sound and how it is connected to mathematics. Music is an art form that has been around for centuries. It is a universal language that can evoke emotions and feelings in people. But what is music? At its core, music is sound. And sound is a physical phenomenon that can be explained by science. In this video, we will explore the relationship between mathematics and music. We will discover how the two are intertwined and how mathematics can help us understand the science of sound. We will also explore some of the mathematical concepts that are used in music, such as frequency, wavelength, and harmonics. So, sit back, relax, and let's dive into the fascinating world of mathematics and music. To understand the relationship between mathematics and music, we first need to understand the physics of sound. Sound is a type of energy that travels through the air in the form of waves. When we clap our hands, we create a disturbance in the air, which creates a sound wave. The sound wave travels through the air and eventually reaches our ears, where it is interpreted as sound. Sound waves are created by vibrations. When we speak, sing, or play an instrument, we create vibrations that travel through the air as sound waves. The pitch of a sound is determined by the frequency of the sound wave. The frequency is the number of vibrations per second and is measured in Hz/He. The wavelength of a sound wave is the distance between two consecutive peaks or troughs of the wave. The wavelength is related to the frequency by the speed of sound, which is approximately 343 meters per second. The amplitude of a sound wave is the height of the wave and determines the loudness of the sound. The greater the amplitude, the louder the sound. In summary, sound is a physical phenomenon that can be explained by the physics of waves. The pitch of a sound is determined by the frequency of the sound wave, the wavelength is related to the frequency by the speed of sound, and the amplitude determines the loudness of the sound. Now that we understand the physics of sound, let's explore the mathematics of music. Music is based on a system of notes and scales, which are organized according to mathematical principles. The most common scale used in Western music is the chromatic scale, which consists of 12 notes. These notes are organized according to a mathematical formula based on the frequency of the sound waves. The frequency of each note is determined by the formula F equals 2n/12 *f0, where 0 is the frequency of the first note in the scale and n is the number of half steps from the first note. This formula allows us to calculate the frequency of any note in the scale. For example, if the first note in the scale is a Fa with a frequency of 440 Hz, then the frequency of the next note, a #4, would be 466.16 Hz. The mathematical relationship between the notes in a scale is what gives music its structure and harmony. When notes are played together, they create chords, which are also based on mathematical principles. The most common chords used in Western music are triads, which consist of 3 notes. These notes are spaced apart according to a mathematical formula based on the frequency of the sound waves. In summary, the mathematics of music is based on a system of notes and scales that are organized according to mathematical principles. The frequency of each note is determined by a mathematical formula, and the relationship between the notes creates chords and harmony. Musical instruments are designed to produce specific frequencies and wavelengths of sound waves. The science of musical instruments involves understanding how these instruments create and manipulate sound waves. Stringed instruments, such as guitars and violins, produce sound by vibrating strings. The frequency of the sound is determined by the length, thickness, and tension of the string. Brass instruments, such as trumpets and trombones, produce sound by vibrating the player's lips against a mouthpiece. The frequency of the sound is determined by the length and shape of the instrument. Percussion instruments, such as drums and cymbals, produce sound by striking or shaking a surface. The frequency of the sound is determined by the size and shape of the instrument. Keyboard instruments, such as pianos and organs, produce sound by striking or plucking strings or metal bars. The frequency of the sound is determined by the length and thickness of the strings or bars. Electronic instruments, such as synthesizers and electronic keyboards, produce sound by generating electrical signals that are converted into sound waves. The frequency of the sound is determined by the programming of the instrument. In summary, the science of musical instruments involves understanding how different instruments create and manipulate sound waves. The frequency of the sound is determined by the physical properties of the instrument, such as the length, thickness, and shape. The intersection of mathematics and music is a fascinating area of study that has been explored by many great minds throughout history. One of the most famous examples of the intersection of mathematics and music is the work of Johann Sebastian Bach. Bach was a master of counterpoint, a technique that involves combining multiple melodies in a harmonious way. Bach's music is based on mathematical principles, such as symmetry, proportion, and harmony. His use of mathematical patterns and structures has been studied and admired by mathematicians and musicians alike. Another example of the intersection of mathematics and music is the work of Pythagoras. Pythagoras was a philosopher and mathematician who discovered the mathematical relationship between the length of a string and the frequency of the sound it produces. Pythagoras' discovery led to the development of the Pythagorean tuning system, which is still used in Western music today. This system is based on the mathematical relationship between the frequencies of the notes in a scale. In modern times, the intersection of mathematics and music has led to the development of new technologies and techniques for creating and manipulating sound waves. Digital signal processing, for example, uses mathematical algorithms to process and manipulate sound waves in real time. In conclusion, the intersection of mathematics and music is a rich and fascinating area of study that has contributed to the development of music and technology throughout history. By understanding the mathematical principles behind music, we can gain a deeper appreciation for this art form and the science behind it.